Good morning. It's great to be here with you today. As Louise said, I'm Kathryn Van Weerdhuizen. I'm a market manager for Oxbo, and we specialize in harvesting equipment for specialty crops. So what we're going to talk about is mechanical harvesting, and we're a manufacturer. So we do everything from design all the way to manufacturing our whole goods, and then we even in some cases do sales and service support. So we have been doing mechanical harvesting for a long time. Our roots go back to the 50s and the 60s with vegetable harvesting. Originally, the technology there, and then fruit in the 80s. And I'm going to keep us on track from a time perspective. If I can get the slide to advance. All right, harvesting fresh produce. So what do we do today? We harvest berry crops for the fresh market. One of the distinguishing factors of berry crops that we harvest is tall, thin rows. So over the row applications where we go over top of the row and we shake and catch. And so there are three main styles of shake and catch when you think about mechanical harvesting. I need to use my hands. All right, so you got rotary style where you have rods that go into the canopy and they spin around on a drum of some kind and they selectively shake, typically selectively shake, sometimes aggressively shake to remove all the crop. You have canopy shaking where you grab the full canopy, shake it back and forth to remove the crop. And then you have trunk shaking, both in small and large format trunk shaking. We do some small format trunk shaking, none of the large format. And then some of the trends in over the row harvesting and those crop types would be super high density, right, where we're growing dwarfing rootstocks, getting those ladders out of orchards and growing trees on smaller format so we can actually shake those canopies either from the trunk, from the canopy, or sometimes with rotary shaking. We also do fresh market vegetables, primarily in the green bean space and the sweet corn space. So our piece is higher volume and more traditional mechanical harvesting. So what does that look like? Well, it can look like a couple different things. So here you've got a 4-row sweet corn harvester, right? So it's cutting the stalk off the bottom, it's popping the full ear off, and it's putting it into a container on the back that can be transported out of the field. This is a smaller format of the same concept. Again, cut the stalk, pop the ears off, and put them in a small container. This is typically for like a roadside stand or someone doing fresh market they can just go out and pick one row for the day and send those ears into to be sold to the customer. They also head to supermarkets, things like that. In the green beans, we do a similar idea where did it not go? Well, that one's not working. All right, well, they didn't download. Anyhow, in the green bean, you're going to see it's going to strip the plant, it's going to pop the beans off, and it's going to put them in the back in a container. And anytime when we're doing mechanical harvesting, there's both removing the crop and then there's almost always some type of cleaning activity, right? You got to remove leaves or other matter that might have got mixed in. And there's always typically some person involved either moving. So even though we're doing high volume, we tend to pick fresh market produce into small containers, right? And so you've got a lot of small containers with only a few pounds of crop typically. And so those, as you're picking a high volume, they have to be switched out pretty routinely. And sometimes you'll see people hand sorting out maybe, bad fruit or broken pieces of green beans. So some pre-sorting by the person who's also moving the containers. In the berry side, so shake and catch, this first video, this is rotary style shaker. This is our orb rotor, which is more selective in blueberries. So unlike green beans and sweet corn, blueberries are a selective harvest crop. So we're going to go over that same row multiple times. Like you heard earlier, you don't want to, and like you all know, right, we don't want to pick the unripe fruit when we pick the ripe fruit. So shaking the plant at certain speeds with certain types of adjustments on the machine can be more selective. And the detachment force of the ripe fruit is less than that of the unripe fruit. The ripe fruit falls off. Now, what's unique about this particular berry harvester, we'll talk about it a little bit later, is a project that we worked on, started as an SCRI grant and moved into work we did with Washington State University, saying, how do we reduce internal bruising of the fruit? It's that type of bruising you can't see until after it's been in cold storage for a while. If you consume the fruit within 7 days, you would never even know that there was micro bruising under the skin. send it by ocean freight to another continent, send it across the country by, by a truck, consume it, 2 weeks after it's been off the plant, and that the micro bruising is going to turn into soft fruit. And so adding those soft surfaces into a machine. So when that fruit falls from the plant, that first drop, it's a pretty high height, right? And that's the big first drop. So if we can protect the fruit in that drop, it reduces the bruising under the skin and improves the fruit quality. So that helps us achieve that fresh market quality by machine, still in a high volume shake and catch scenario, and still achieve that the high volume, which helps justify the cost of equipment. Here we have raspberries, not a lot of fresh market raspberries done machine, but some people, again, are doing that where they're selectively shaking. Raspberries, just if you don't know, you go in about every 3 days and reshake those same plants. So you need to have a gentle shaking action, just remove the right fruit so you can come back in 3 days and pick that right fruit again. And so what you typically see in raspberries, if you're doing more fresh market, is a pretty low volume of fruit coming across, just because, again, you're coming over it so frequently. I think raspberries, for a lot of people who don't understand produce, there's such a, once you get them in the store, right? If you bring them home and you rinse your raspberries, they're not long for this world, right? They're going to get soft really, really fast. And you look at an apple and you're like, man, how can you mechanically harvest a raspberry? And we haven't figured out how to do an apple. Well, the cellular structure of that raspberry, it's for the first 60 seconds after it leaves the plant, it's pretty firm. It has a lot of, those cells hold together really well. So as long as you can pick it and transport it and get a container, you're pretty good. Whereas an apple, as soon as something touches that flesh, you can get bruising pretty easily. So what are the drivers and why do people turn to mechanical harvesting? It's a lot of the stuff that we've heard already this morning. Labor is obviously a big driver, and we hear both stories. We hear both availability, right? In some places, we just can't find people who want to work in the fields all the time. We can't find enough labor to harvest the crops as we plant more and more of this high value crops, because these are typically fresh produce as high value crops. It's a good use of farmland. It's what people want to grow. And also the cost of the labor. If you can find it, you typically can't afford it. We hear about food safety, traceability, about keeping maybe people away from our food, using machines to harvest it so that you're one step away. There's definitely conversation around product volume and acreage. As you put in more and more acres, it's hard for a small group or a small team to be able to cover that space and get that fruit or vegetables, that produce harvested when it's at its peak freshness. And product volume too. So if you think about a berry plant or even that low volume of raspberry, you think about how many berries people would have to pick. Similar to the strawberry conversation that you had earlier, right? And Stavros talked about it too, how quickly people can pick a piece of fruit, but if you need to cover a certain amount of acres and there's a certain tonnage of ripe fruit at that time, you need to have a high volume application to get the fruit out or the vegetables out of the field. And harvest control. When fresh produce is ready, it's ready, right? It has its peak nutrition, its peak flavor. It's when you want to get it out of the field, and when you want to get it quickly to the downstream process, whatever that is. If it's packaging, if it's processing, if it's to the consumer. So people turn to mechanical harvesting just to have that control. Like my produce is ready. I need to get it out of the field. And then product quality. So again, different stage selective harvesting, having onboard systems to pre-clean it before it gets into a packing operation. Those are some of the drivers for mechanically harvesting. What we obviously see are a fair amount of challenges in the business as well. So product quality and sensitivity, as we talked about, not every crop is easy to harvest, and not every crop is easy to mechanically harvest. These products that have quality sensitivities, that they're prone to bruising, that they're prone to defects if you overhandle them, they're a challenge. Selectivity, so a lot of the fresh produce that's already been mechanized, you can just pull it all at one point in time. Right, berries are a little different where you're selectively harvesting. If you're going to selectively harvest and you don't want to damage the next crop, it's very challenging in mechanical harvesting. And just the variability that was talked about earlier. I can appreciate all of the uniquenesses of agriculture and how certain growing styles, certain cultural practices lend themselves to higher quality produce, to more volume, but it is very challenging to have all kinds of different growing practices, different widths, different heights, different tonnages, different row lengths, different positions where you might grow a crop if it's off the ground. Also, you've got off the ground, off the vine, and off of a tree. That's typically the stuff that we do in the fresh produce market. So those are all different activities. Yes, you can see it. Yes, you can selectively harvest it, but it's from different places, right? Maybe you're looking through foliage. And so in shake and catch, it's a great way to get volume, but it's a challenge in fresh produce. And then obviously consumers, right? We want good looking product. We want it to be appealing in the store. And so those are some of the things that we bump into as we manufacture equipment. So we get asked all the time of people about like, I want to mechanize my crop. And I've had the same conversation with so many people around the world fairly routinely. As I'm seeing a smile in the front row, you've had this question too. And we just was talking about it during the break as well. One of the first keys really is acreage, right? Is there enough? Development is expensive. It takes a long time. Iterative development, especially in fresh produce, seasons are short. So you can spend a lot of time, right, doing development. You get a machine ready, you send it to the market, and oh, that didn't quite work how we wanted, or the weather wasn't quite what we were expecting. So you do need to have some type of acreage or some type of driving factor behind it. It was also mentioned in the last session, commonality of platform, and that's extremely beneficial, right? So if we can extend an existing technology into a new space, that's why super high density plantings and dwarfing rootstock is exciting in this space, because we can say, right, if we can get a tree smaller, then we may be able to use some of the existing shake and catch technology, modified slightly, and be able to extend it at a lower cost to the grower into a bigger market. But if you don't have that, if you're going after ground up development, we do need acreage to support development. The size of the product is also a challenge. Very small things like coffee cherries or olives, all the way up to citrus and apples range in size, right? So the physical size of a product, there's a conversation both. How are you going to transport things of various sizes? How much? I have this later on in the list, but how much product volume do you need to store per pass? Because that leads into ground drive consideration, right? If you have in blueberries, you might go down and back and you might have 8,000 pounds of blueberries on a machine that you need to load and unload, right? That is a different environment from a mechanical perspective than, I'm pulling, a couple 100 pounds of a crop out of the field. The product hardiness itself, we talked about that earlier. So conversations we have is like, okay, what is it? If it hits other product, is that going to damage it? If it hits a belt, how high does it fall from? What's the detachment force? What's the product volume that's coming off? You saw in some of those videos, right? A couple raspberries trickling off into a really flat container versus a bunch of blueberries coming off into a 40-pound lug versus a bunch of ears of corn going into a big box, right? Different product flows. It was mentioned in an earlier session this morning, right? You have different size product. It comes across and you need to plan for different transport, right? Is it a belt? Is it a tube? How are you going to get it from where it came off to where it's going to go into the container? How are you going to get the container off of the machine into the next stage in the process? One pass versus multi-pass, this consumes a lot of our thinking and a lot of our time. If it's a single pass, that's maybe you have a little bit more that you're not going to be able to use from a consumer perspective. Or versus multi-pass, you're going to go over that ground multiple times. You could be doing damage. You need to pick, in blueberries, we say all the ripe fruit, but only the ripe fruit on every pass. Because if you don't pick the ripe fruit, guess what? Next time it's soft and moldy and not usable. But if you overpick the green, you have less sellable product next time. Again, cultural practices and constraints, commonality. Can we grow things in a similar row width? Can we grow them in a similar bed size? We all have very unique ways of growing things, and that does make it challenging, especially in permanent plantings. There's maybe a little bit more flexibility if you put it in the ground each year, but there's not much, right? Because there's a lot of existing equipment in that space. Harvest window, field conditions. It was mentioned earlier about light equipment. And okay, we don't pick in the rain, sure, but I've also seen, broken irrigation lines. That makes it a mess out there. And then the piece of equipment gets stuck because it doesn't have the gradability that you need. You've got blow sand in Peru, and you've got peat ground in Northwest Washington, and you've got, the valley floor here. And so as you go around the world, right, there are challenging ground conditions that you have to take into consideration. And that drives, how stable does your platform need to be? Even if we talked about earlier, automation versus full robotics, let's say you would have some autonomous robot just moving crop on top of a mobile platform. Well, it needs to be very stable then. And so what does that translate into ground drive? So field conditions. How about field size and road movement? There are constraints to machine size to transport on the road. So you're going to transport it by truck, or are you going to road it? How fast? Okay, if you're going to road it, have you ever been behind a 7-mile-an-hour berry harvester on the road? I make them, and I don't like to follow them on the road. But there's design criteria around how fast can it go if it's going to drive itself down a road. How wide can it be if you need to ship it on a truck? We want to have big machines sometimes. Well, then the field needs to be a 1-to-1. And can you justify a 1 machine to 1 field? And then cleaning and sorting. So we also have, in addition to, okay, let's just get the crop off and put it into something. Typically, there's some byproduct that you need to clean out. So maybe it's leaf, maybe it's just, it's mostly leaf. It could be sticks or twigs. It could be bad product. Are you going to sort that out in the field? Are you going to leave that organic matter in the field? Or are you going to bring it into a processing plant downstream? So these are all the fun conversations that we get to have in the field. And it was also mentioned before, but varieties and all of the genetics that go into having harvest conducive varieties. It really has to be a full package idea. So where are we going? I mentioned it earlier, but we are big on collaboration with universities, with government research, with industry, and with customers. So together, we have to do this together. No single one of us is going to be able to do it by ourselves. There are certain resources available at the university level or through government research that enables us to pull a lot of expertise that wouldn't be otherwise available. It's come up with some great proof of concept, some good starting points for additional mechanical harvesting, but also industry and customers. We need to understand, it was also mentioned before, right? What can we change? What can we not change? And downstream processes are also important to think about. Where's this fresh produce going to go? How quickly is it going to get to the consumer? What's the next? Are we going to pick it into the container that it goes to the consumer? Or are we going to pick it into a intermediary container that then gets put into some different size for the consumer? What does that look like? Breeding and plant improvements. So we're actively working with breeders and making equipment available as they try to breed stuff for machine harvest that also tastes good, that also looks good, that also has the yields. So we're trying to make equipment available in those to those people. And again, cultural practices, the more common systems are, the more cultural practice have some commonality, the more we can take technology and iterate it and use it to solve the next problem. Mechanical harvesting versus harvest aids, it was mentioned in the, having N arms on a robot doesn't equal, that much, and it doesn't multiply necessarily your effectivity. What we've seen with harvest aids is that's often true, right? I mean, human harvesting people, they're extremely effective and they're extremely fast and they're extremely good at their job and they're extremely hardworking. And when you tether them to a harvest aid, you often lose a lot of that efficiency. And I mean, I think we're all competitive too, right? Like I want to be the best. If I'm out there handpicking, I want to be the best at it and be making a good day's wage. And so when you tether people to harvest aids, you don't end up with the gains that you're typically hoping for. And we've seen that in a number of projects that we've been involved in. So mechanical harvesting gives you some additional value that you don't necessarily see what you would expect with harvest aids. So equipment trends, similar to the robotic space, more sensors, more data management on equipment is what we're seeing and what we're driving today. So digitalization of equipment, fleet management. This is a screenshot I took out of our fleet management software just from last week, right? So you're seeing, this is the number of yield and flats and pounds coming out of a blueberry field, actively harvesting. How many engine hour, is it actively on right now? Do the settings match the other ones in the field? Should they? Maybe they shouldn't. Did somebody bump a lever and now you're, running at way too high of head speed and going to be doing damage. So we're working at, especially in multi-pass crops, understanding how many pounds are coming out of the field. Ease of use technology. So it's the how do you make it easier for the operator? So there's an operator that typically is less trained than they were 20 years ago coming in. They might have never driven a piece of ag equipment before, and they're going to get involved with this piece of equipment. So we want it to have auto steering so that they're less involved with steering, keeping it on the row, because ground loss, whether you're doing robotics or mechanical harvesting, ground loss is a big deal. You shook it off the plant only to drop it on the ground. So the more you stay, especially in over-the-row technology, the more we stay centered on the plant, the more crop we collect and then can put in the container. Ground following, that's about height adjustment. So you want to be able to follow the ground, right? You want to stay low. My least favorite phrase in the business world is the low-hanging fruit is the easy stuff. The low-hanging fruit in my world is the hardest stuff to get. So if you could just stop using that phrase, that would be great. But you want to stay as low to the possible as the ground until you start pushing dirt, right? So you can get, especially in permanent plantings, there's a lot of fruit that hangs close to the ground, and it's good fruit, but somehow we got to get underneath it and collect it. And then return settings. So that's the concept of, I get to the end of the row and I turn the machine around. So the faster you can, that's inefficient time, whether it's robotic or it's mechanical harvesting. Anytime you have to turn it around, that's inefficient. It's not actively doing anything. So how do we help the user get to the next row and get the settings back on and get to harvesting again, whether it's the user is a person or the user is, maybe it's doing it itself. But that time at the end of the row, and also loading and unloading fruit products or fresh product is another piece of inefficiency in the chain that we're working on. Let's see if these videos will work. Also, equipment trends are yield. So people are looking for yield for a couple of different reasons. On the right-hand side, you see a yield map of grapes that we're generating with our customers. So you can see that there's definite trends out in the vineyard of low yielding and high yielding areas. And they can use this map season over season to understand, maybe we should stop putting inputs into those low yielding areas. Maybe we should just stop, applying a bunch, it's just not going to produce. Or alternatively, maybe we need to focus on those areas. Maybe it's a soil quality issue. Maybe it's a water issue, but to understand when you see your whole field laid out, where your low and high yield areas are. The other piece of yield is saying, again, we want, if you think about downstream processes, in blueberries, you want that consistent lug weight. You want all of them to have the same amount of fruit in them. Even in a high volume crop like wine grapes, right? There's a downstream process of a winery who's expecting a 24-ton load of a truck to come dump its fruit. So you think about what's the downstream process, and we have developed technology that helps the user, as you see here. This light, if you can see, is going to go yellow, which says, okay, your container is getting to the weight that you wanted, and it turns green and it says, okay, that one is full. And so that way we can have consistent lugs that all weigh the same. And if you think about automated dumping and a processing facility, there's a lot of value in having consistent weight. Now, also, now that we're weighing it, now we can tell you how many pounds you're pulling off of that row or that field. And you can still see, even in mechanical harvesting with this high volume crop of blueberries, there are a lot of people involved still, because there's a lot of crop coming off every few seconds. And all this fruit that you're looking at is heading to the fresh market. So consistent container weight, variable yields, and also variable spraying maps. So you can start to correlate that variability in your yield maybe to what you've applied over the season.
No, don't worry about it. No worries.
I told you I'd get us back on track.
Okay.
It's my secret gift.
You mentioned the aspect of food safety and removing people from the equation. But at the same time, I was thinking about in the blueberry where you showed the one photo of the soft surfaces and the berries coming down and hitting those surfaces. So my question is, how do you clean that equipment to meet food safety criteria? What are the procedures there to maintain that cleanliness that's needed?
Yeah, absolutely. That's a great question. So on all the materials, we make sure that they are food safe materials. So that's step number one. And then typically for cleaning, individual growers have individual cleaning regimens for their full machines. So, you know, whether it's just water, it's water with a detergent, all of that stuff can just be washed down.
So that would be done on a daily basis?
Typically, periodically or daily. It does depend on the customer and the application.
All right, thank you.
Mm-hmm.
You mentioned also the use of blackberries, right?
Yeah.
So I am wondering how the amount of percentage of damage that you can see, you know, because one of the main issues in blackberries is the defect name regression of red cells.
Mm-hmm.
So it is an issue from Mexico constantly because the vibration.
Yep.
So because the amount of vibration, the speed that I saw in the video was huge.
Yeah.
So I'm wondering how you guys can control that? Or
yeah, we can definitely control the amount of vibration, and it is variety based, right? Some perform better than others, and typically in blackberries or raspberries, it needs to be very fast to the consumer. The technology is not there yet to say, you know, you can wait 7 to 10 days for a consumer to eat that particular fruit crop.
Thank you.
Yeah.
No, basically for distributors, we try to keep blackberries maximum 3 days.
Yeah.
Or 4. But after that,
it's too late, right? Yeah.
Just a quick question. Are you guys in the business of selling machines or providing a service?
We sell equipment, but we also service it. So typically in the ag, I guess I was gonna talk about that. Service is a big piece of ag machinery, whether it's whatever type of machinery it is. And so we do a traditional model where you would buy the piece of equipment, but there are a lot of contractors in the space that maybe, you know, a lot of times they maybe were labor contractors before, and now they use equipment either to supplement their labor contracting business or as their only business to provide harvesting equipment. But it's about, uptime is a big deal. So we don't do harvesting as a service. We like to make equipment and make sure it stays running.
I have a simple question. Of all the machines that you showed us, or the machines that you sell, which is your favorite and why?
It's like asking my favorite child.
Yeah, I know. That's why I'm asking that question.
I think today, the most exciting space for me is blueberries. And that's just because of the growth in the blueberry industry globally. It's about the excitement behind better technology in blueberries, and you know, the fruit itself is incredibly good for you, and pretty much everybody likes to eat it. I like the fact that it's a fun business to be in. Everybody likes to eat my products. So, but don't tell the corn and bean guys that I said that. Yeah.
Thank you.